Up until this point, we've learned that sound is what we hear, and we've also learned that sound is a result of vibrations. Okay, so at the source of the sound there's some vibration taking place, and we hear the sound because our eardrum vibrates. Okay, so when the sound is produced, it travels in waves. And when these waves arrive at the eardrum, they cause it to vibrate. So on one end there's a source of sound that is vibrating, and at the other end the eardrum is vibrating, following the waveform of the sound. Okay, so this simply means that in whatever pattern the vibration is taking place at the source of the sound, the same pattern the eardrum vibrates. That's what it means, following the waveform of the sound. But what exactly is a wave, and what is a waveform? Now, Wikipedia defines a wave as: a wave is a disturbance or oscillation that travels through space and matter, accompanied by a transfer of energy. Okay, so this is what Wikipedia says about wave. A wave is a disturbance or oscillation that travels through space and matter, accompanied by a transfer of energy. Now, how that transfer of energy takes place and how that disturbance travels through space and matter, let's have a look. In order to understand how the wave mechanics work and how the wave travels, let's look at this simple illustration. Imagine there's a large bottle filled with fuzzy water, and inside the fuzzy water you can see the bubbles floating around. Okay, let's also assume for a while that inside this water bottle we've got a solid bar on one end, which we somehow, let's say through a remote control kind of thing, we can push it back and forth. We can push it inwards, inside, towards the center, and outside. Now, can you imagine for a moment what will happen if the bubbles are swimming around and you push this bar, this solid bar, inside, inwards, towards the center? What will happen? What should happen? Let's see. The bubbles are swimming around, and as soon as we push the solid bar inside, as you can see, as the solid bar moves inside, it pushes the bubbles. It creates a wave, some kind of a force, some kind of energy which kind of pushes the bubble inwards, and it pushes the bubbles to get closer together. Okay? And now the bubbles are still swimming around, but they are much closer together. And what will happen if you push this bar back? The opposite kind of force is created, which pulls the bubbles back to their original position, and now they are farther apart. Now, this seemingly very simple idea is the key to understanding the mechanics of wave. Now, this part, when the bar is pushed inside and when the force is applied to a set of particles so that the particles get closer together, this phenomena is known as compression. Okay, it's known as compression. Let's write it down. Okay, pretty cool. So this is called compression. Now, moving ahead, when the bar is moved back, what happens? A force causes the bubbles to be pulled apart. So now they are farther apart as they were before. So this phenomenon is actually known as rarefaction. Okay, let's write it down. Rarefaction. Okay, compression and rarefaction. These are two important ideas that we need to understand in order to understand how the waves work. Okay. Moving ahead, let's see how this idea works in actually transferring the sound from one place to the other. Okay, here we are back again. We've got the same illustration of our guitar, same old guitar, okay, with a single string running through it. And as we know that when there's some vibration, such as the vibration of this string, the sound is created. Okay, and now we are trying to understand that how that sound actually travels from one point to the other. Okay, so this is what happens. Also assume that these tiny dots right here, these dots, let's assume they represent the tiny particles which are in the air. Okay, of course this whole thing is a very, very overly simplistic illustration of a very, very complex idea, but just to make you understand, just to keep things simple, let's assume these dots are actually the air particles. Now let's see what's happening. Okay, I'm pretty sure you have already figured it out. What's happening? See, as the string is moving one way, it is causing a force, a similar force that caused the bubbles in the bottle to go closer, to move closer together. A similar force in the air is exerted, causing the air particles to bump into each other and get closer together. And when the string is moving the opposite direction in the vibration, it is causing the opposite force to pull these particles farther apart. Okay, so this is compression in action, and this is rarefaction in action. Okay, so all the time when the sound is produced, there is always compression and rarefaction, because sound is a wiggling of some matter, vibration, and that vibration is causing the air molecules to go closer together and then going farther apart. Also notice that when the molecules bump into each other, they transfer the force from one particle to the other, and that is the key of sound traveling. Okay, so the actual force is applied to this applies the force to this applies the force to this, just like a billiard ball effect. One ball applying force to the other applying force to the other, and that's how the energy transfers from one point to the other. Okay, so that is almost half of the solution to the puzzle. Now, how this sound gets to our ears, let's see. Again, I'm sure by now, if you're smart, which I am sure you are, you must have already guessed what happens, how we actually hear the sounds. Now see, again we are back to our ear illustrations. So here is our string, vibrating string, and these dots represent the air particles, and here we've got our tiny tympanic membrane, our eardrum. Okay, and what we need to do, we need to make this guy vibrate, because if this guy vibrates, then we hear the sound. If this guy doesn't vibrate, we don't hear any sound. So how does this guy vibrate? This guy vibrates because it's getting the force from these air particles. So it's a chain reaction. It's a cause and effect. As you can see, compression, rarefaction. And when the string is moving one way, it is pushing the particles together, and that force is all the way transferred till this point, which pushes the eardrum one way. And when the string moves the other way, it pulls the particles back, okay, further apart, and that pull, that force of pull is causing the eardrum to be pulled also. Okay, so as you can see, the eardrum is vibrating in the same pattern as this string is vibrating, and as a result, what happens? Something very, very amazing happens. We hear sound.